We've seen that for our x0, y0 observation 3.630 with uncertainties of plus or minus 0.4 and plus or minus 2 respectively in the x and y values, our f of x, y values appears to be around 4.6 plus or minus 0.9, with the plus 0.9 occurring if we have a positive change in y and a negative change in x. Returning to our former picture, where x0, y0 is this point, and we'll regard that as understood. Here's x0. At this point we have x0 plus delta x. At this point we have x0 minus delta x. At this point here in the center we have z equals 4.6, meaning that if we evaluate the function at the x0, y0 point that we observed, we get 4.6. At this point here, where we've moved in the negative x direction and the positive y direction, we get z approximately equal to 4.6 plus 0.9. Were we to move in the positive x and negative y direction, we would expect z to be approximately 4.6 minus 0.9. Recalling our calculation, recalling that the 0.6 was our fx delta x and 0.3 was our fy delta y, for a delta x of negative 0.4, delta y plus 0.2, we would have z value 4.6 here, moving in the negative x direction. That increases by 0.6, so we would expect at this point for z to equal 4.6 plus 0.6. And if we move in the y direction, we expect the change to be 0.3. So we would expect at this point that z would be about 4.6 plus 0.3. The 0.3 difference that we get between here and here should be the same as the 0.3 difference we get between here and here. Should be approximately the same, maybe a slight difference because of the change in the y coordinate, or in the y derivative as we move to slightly different values of x. Down here, of course, we have this value. We could also figure the approximate values at this corner, and this corner. Let's just do this corner. We expect z to change by negative 0.6 as we move a delta x in the positive x direction. So z here would be 4.6 minus 0.6. But then if we move in the positive y direction, we would expect, again, an increase of 0.3. So we would have z equals 4.6 minus 0.6 plus 0.3. If we want to be numerical about it, we could actually calculate these values. This would be 5.2, this would be 4.0, this would be 4.3, this would be 4.9, this would be 5.5, and this would be 3.7. Our maximum value of z for x, y values in this region corresponding to the observation that x0 is 3.6, delta x plus or minus 0.4, y0 equals 30, delta y plus or minus 2, is this picture. That our actual value of x and y corresponding to our slightly uncertain observations has to lie between 3.7 we get here and the 5.5 we get here. all these numbers, all the numbers we get, and we could figure out a number here and a number here, all the numbers are going to be between the 3.7 and the 5.5. That is f of xy equals f of x naught, y naught, plus or minus delta f at every point of this region. And we're going to call this region the possible region. Now that's my own term. Don't use that in polite society. Nobody will know what you're talking about unless you define it for them.